Welcome to MDC 325B, so hopefully you're in the right room. My name's Jeff Alexander. I'm a technical evangelist here at Microsoft, as well as the content owner for this entire event. And one of the big parts of the event is our sponsors. So our sponsors are very important to us, both from the event perspective, but also from the partners that we have that integrate into products like Windows Server and System Center. So today we've got one of our great storage partners in NetApp talking about all your cool stuff, right? That's all their cool enterprise SANs. You're going to see some real good integration into Windows Server 2012. So I hope you enjoy that. So first of all, I want to introduce Corey Adolphus, who is a solution specialist here at, where are you located, in Sydney?
Yeah, Melbourne.
In Melbourne. So he's located in Melbourne. He's your local guy here. And we've also got out from North Carolina.
Yes, sir.
Yes, we do. We have Glenn Sizemore. So give these guys a great big welcome. They're one of our key partners in this space. And I hope you enjoy the session. Thanks, guys. Oh, and you got giveaways, right? You guys got stuff to give away?
We do.
Awesome. All right, I'll let them tell you all about that. I'm going to jump off and hope you enjoy the session. Have a good one, guys.
Thanks, Jeff. So yes, we encouraging questions. So please raise your hand and ask away. And we've got some mushroom speakers and some T-shirts here. So there is no dumb question. Every question gets one of these speakers or a T-shirt, whichever you prefer. So please ask away throughout.
Okay. And with that, we'll go ahead and we'll get started, guys. Again, it's my job to get you out of here on time. It's your job to learn something. So if we're not clear on something or you want more information, just raise your hand and let's go. So on the agenda, we're going to start with a brief introduction to what NetApp is, in case you've never heard of us before. Then we're going to move into and cover something that's starting to kind of emerge here recently, which is software-defined data centers, and what that means to the industry and what that means to storage and partners like NetApp. And then we're going to dive right into Windows Server 2012 and System Center 2012, which are really how we deliver on this promise of deliver IT agility in the modern data center with integration of virtualization, cloud, and apps. That's a big title. Okay, so getting right into it, we got a lot of content to cover. Who is NetApp? We are a Fortune 500. We are a storage company. All right, we sell storage. 77% of the Fortune 500 are NetApp customers. We are perennial best place to work winners and 100 best companies and most innovative companies, yada, yada, yada. We take our culture very seriously at NetApp. It's one of the things that we pride ourselves on, is being a wonderful place to come to work and innovate and come up with new technologies. And because of that, we tend to enjoy our customers a little bit more. But that's what's good for me as an employee. What's good for you, and the reason you care about us, is because we are the inventor of and caretaker to the world's #1 storage management operating system, Data on Tap. We are also Microsoft's 2013 Server Platform Partner of the Year. That one's kind of odd, isn't it? We're a storage company. Server Platform Partner of the Year. How do we do that? Previously, we were the Private Cloud Partner of the Year and a runner-up in Management and Virtualization. Again, two categories that don't directly associate with storage. So how did we do that? Well, the answer is by putting the time and effort in to deliver the deepest integration in the industry into the Microsoft stack. You know, the beautiful thing about the way that Microsoft builds products and solutions is they built a portfolio that's rich in APIs and plugins and partners and gives us the platform that we need to be able to give you the tools that you need so that we're all successful throughout the entire stack. We call this the Lego slide. You know, here we break up the data center into various levels, you know, starting at hardware all the way up through virtualization, management, orchestration, administration. And what you'll see is that every single layer, we have both the functional job of the layer and then the part of the business or what that layer is providing. But then you'll see that Microsoft has a native component that solves that problem. And what we've done is at each stop in this progression is provided that plugin to light up those endpoints, right? So that when you go into the menu or you go into the GUI, you go into the API and you try to do something, we're going to take advantage of all of the extensions that they've made available to us. So that's a really quick 2-minute introduction to what NetApp is. If you'd like to know more about that or anything you're going to see here over the next 60 minutes, come on down to the booth and we'd be more than happy to give you more information. So now let's get into it. Software-defined data centers. It was interesting. Last week I was at a different event in San Francisco, and there was another company who was trying to pretend that they invented this, which not really. It's been around for a while. What is software-defined data centers? A lot of people think that software-defined data centers mean that all of a sudden we're going to remove hardware right? Software-defined networking, software-defined storage, software-defined virtualization, yada, yada. It doesn't mean that we're going to get rid of the hardware. What it means is we're going to start pooling these resources and treating it differently, right? We're going to define in software what our service policies and service levels are for any given stack inside the data center, and then through those policies and those service levels, we will then virtually or abstract away what we want the data center to look like, and then the orchestration and management platform is then going to handle that. Right? So that's really what that means, or at least that's what NetApp believes that means. And within the software-defined data center, of course, it's spanning the entire architecture, because we got to have a beginning, middle, end view of the architecture. Compute, network, storage, and security. Focusing specifically on the storage part of it, there's another emerging trend that we're starting to see more and more interest on, which is software-defined storage. Now, part of the reason that software-defined storage is coming out at all in the first place is because we've hit this apex of complexity. You know, at this point, there's so many different layers of abstraction and virtualization going on in a modern data center that it's really, really hard to wrap your head around what's going on. And because of that, we're starting to running into spiraling costs, unexpected downtime, and when you do have an outage, the impact of the outage is often greater than anyone ever anticipated, because no one truly it's really hard to get your head around all the various interdependencies that are going on in play. You just kind of take this stuff for granted until something breaks. And again, because of that complexity, at greater scale, the costs are just spiraling out of control. So what does software-defined storage do to solve this for us? Well, first and foremost, it takes the complexity out of it by, again, just like software-defined data centers take the physicality and break it into policies, software-defined storage takes the physicality and you break it into policies and service levels. And then through those service levels, you build your templates. And then when you start doing your provisioning, you're provisioning from templates in a service catalog that's enforced policy-based management, right? So this is just like the old song and dance about, if you do it by hand, that's great. But when you do it by hand 500 times, inevitably 3 of them you mess up. So you automate it, and then all 500 of them work. Well, this is the same concept, only applied at data center type scale, right? And then from there, we go from data center to cloud scale with the new Cloud OS. So in NetApp, we break SDS, or software-defined storage, again, into 3 primary categories. The first one, of course, is self-service. Self-service is the primary tenet, as far as we're concerned, when it comes to cloud. It is where it begins, it middles, it ends. If you don't have self-service, it's not a cloud, it's just virtualization, right? So that's the first tenet that we have to deliver, and we cannot compromise. Then we have virtualized storage arrays. Now, because we are a hardware-based storage provider, we have to rationalize what that means. That doesn't mean vSANs or virtual storage. That does mean that there is hardware in place, but it means that we have to give you flexibility and choice on how you're going to actually deploy that operating system. And then we need to support multiple vendor hardware, because again, deploy on the platform of choice, and we'll go into what that means here in a second. So starting with the virtualized storage services, this is where the provisioning and policy template approach comes into play. Instead of coming in and saying, here's the SAN has so many disks, I'm going to create a RAID, and then I'm going to create LUNs, right? Instead of that, we create logical management constructs. We call them storage virtual machines, or SVMs for short. And inside those SVMs, we then, by policy, declaratively declare that they're going to have storage services, for instance, SAN or NAS. And then we, by policy, declaratively declare that they're going to be storage efficient. They're going to have features like dedupe and compression and thin provisioning. And then, of course, the whole system has to be cloud ready. So we have to support multi-tenancy. That's the really, really important part, and that's actually one of the hardest parts to do, but we think we've done a pretty good job of simplifying that. Sorry, Joe. And then throughout the stack, we need guarantees. Well, one of the hardest things from a storage perspective is not, once you get it deployed, how do you solve the noisy neighbor problem? Now, Microsoft is actually going to make this easier for us here in a couple of months when R2 comes out, but for how do we do it today? And for our answer to that is through granular QoS policies, integrated data protection, so an end-to-end view of the architecture. We'll have a small snippet of what that means to us. And then data mobility, and that's the one that's going to be real fun here at the end. So multi-vendor, what does multi-vendor mean? Well, we have a unified operating system. That's the #1 management OS that I mentioned before, clustered data on tap or data on tap. But it's an OS, it's software, Now that software can be deployed on many platforms. As you can see here, we have our unified and optimized primary delivery mechanism, which is our FAS series, or our FAS storage controllers. And that's what's featured in our integrated stack FlexPod architectures partnered with Cisco. We can also virtualize your existing arrays, so your existing EMC 3-PAR HP. We can put our V-Series FAS product in front of that, and you get all the benefits of cluster data on tap without having to buy our disks, right? So if you like your current disk provider, that's fine. What we're selling isn't disks, it's intelligent storage management, right? That's really where our value is. And then for commodities, or for the robo play, we have what we call on-tap edge, which is where we're taking on-tap, and in this case, it is a VM. There is no hardware. It's just a VM that you put on commodity hardware and use your existing third-party arrays. And then we have to start to take a look at the cloud. Now, the first instance of this is our NetApp Private Storage for Amazon Web Services. But really what that is NetApp Private Storage for public cloud. And we have many other public cloud providers coming online very soon. But if you'd like an idea of what it looks like, just look up the AWS instance. They don't change very much when you go from one to the other. And then getting back to the self-service, because again, this is where we're going to set that stake in the ground and say this is where the bar you have to reach. Otherwise, you're just making it up as you go. And our answer to that is to empower you and to empower our developer community by offering the most programmable and API-rich storage platform there is. Everything you can do in our arrays, everything you can do in our software, everything you can do in our management products is available through a rich API subset, and we expose those interfaces and make them easy to digest in whatever language you may choose, whether that be a developer environment and use something like C# or VB, or an administrative environment, something like PowerShell or Python, or the pure web developer. And then we take those APIs, and we as a company then deliver some deep integrations for some examples and some off-the-shelf implementations with our partners, such as Cisco, Citrix, Microsoft, implementations with OpenStack, Red Hat, Oracle, and et cetera. So again, NetApp's SDS vision and approach, we got kind of railroaded with cloud. You know, cloud became a marketing term before we had defined architecturally what the technology meant. So what happened is, by the time we got it right, we'd come to shows like this, and we'd get up in front of you and say, here's our cloud solution, and everybody would roll their eyes and put it in their earbuds, because it sounded like a marketing pitch. We were trying to get out in front of this one and tell you what the architecture looks like so that we don't get co-opted by marketing. So this is what we mean when we say software-defined storage, right? And this is what software-defined data centers mean when NetApp is in this space. So again, that's just an emerging trend, something to be aware of. And hopefully over the coming years, it'll start to make more sense. So now let's get into the brass tacks of how we actually start to do this stuff, and this is where it starts to get fun. Windows Server 2012, it's got its baby brother coming out in the next couple of months. For the most part, everything we're going to talk about today is based on 2012, not on R2, but nothing changes. From a storage perspective, all the features and functionality and enhancements that we're going to discuss today, all of it just works in R2. Right, so it's not like, oh, well, this isn't relevant. Yeah, this is shipping today. It's available today. It works today. And in 6 months or 4 months, when R2 ships and GAs, all you'll have to do is install the new bits, and everything will continue to function just as before.
6 weeks. Yeah.
6 weeks. Oh, God, it happened fast. This year's gone by in a blur. Okay, so breaking up Windows Server. Sorry. Windows Server 2012 had a series of major payloads and a series of major commitments that make it different from just about every server release that we've ever seen. The first, in my opinion, the first and one of the largest was they really spent a lot of time and took a hard swing at the management component, at making Windows manageable again. There's a reason that the entire world runs on Windows Server. It's already the premier hosting platform from an API and support perspective. But as any IT pro knows, when you start to try to manage those systems at scale, it started to fall apart. Not so with Windows Server 2012. 2012 had all the APIs, all the management, all the plugins and PowerShell integration you never want. From a storage perspective, they gave us 3 primary components to plug into. First and foremost is the IT Pro interface, and that's PowerShell. at NetApp, we have what I believe to be the richest PowerShell implementation in the storage industry in our Data ONTAP PowerShell toolkit. It is a Windows PowerShell wrapper around the Manage ONTAP SDK. Those are those APIs that we were referring to earlier when we were talking about our extensibility and application self-service. It is a community-driven product. What that means is, if you download it and you don't like a commandlet or you think we're missing one, you go to our communities, you tell us about it, you wait 4 months, and you get it. We ship every 3 months on a clock, a quarterly release cycle, and we let our community tell us where the holes were driven. This toolkit has been out in the world for 3 years. The first version had 127 commandlets. We're currently up to 1,400. Right? We got to 1,400 by listening to our users and building and filling the holes that they told us were out there. And again, as of version 3.0, which shipped 2 months ago, we've got another version coming out next month. We're currently at 1,400 commandlets. So just an absolutely massive implementation. We can do absolutely everything in the box, from bare metal provisioning all the way up through tenancy. We've got a couple examples of what some of this looks like coming up. And then we've got the standards-based approach in SMIS, storage spaces inside File Services Manager, inside Windows Server 2012, can leverage SMIS as well as SCVMM for a more holistic view. SMIS is the standards-based approach to managing third-party arrays such as NetApp controllers. Our current SMIS provider, version 5.0, supports all currently supported versions of Data ONTAP 7.3, 8.0, 8.1, and 8.2. It is agent-based and can be hosted from either a Windows or Linux machine in a VM or physical host. And we have passed the SNIA Conformance Testing Program, CTP, which is required for SCVMM 2012 SP1, and will be required for the R2 update when it ships later this year as well. We also have our GUI, which is SnapDrive for Windows. SnapDrive for Windows, for those of you who are familiar with us, it's been around for a great many years. We still continue to develop it and publish it. We're not going to demo it today because it's really not as important as it once was. It's primarily becoming our backup solution. It is where we ship our hardware-based VSS provider for our bare metal block LUNs and then for our SMB3 implementation. But if you're just doing provisioning these days, PowerShell is the premier way to do that, and we'll see why in a minute. Okay, so I have been babbling for 20 minutes. Thank you very much. Now let's start to get into the demos, okay? How many of you have used SMIS to provision storage in Windows Server? Nobody. Nobody knows about this feature. It's so cool. So we're going to do that right now. So here we have a failover cluster. We have 2 CSVs, but we want a third one. So we're going to launch Server Manager. And then we'll go into File and Storage Spaces, into Storage Pools. Storage Pools is going to reach out to our SMIS provider. It's going to load that information from our array, and you'll see it come in. Our aggregates are going to be represented here as pools. If we click on a pool, we'll see the physical disks that are actually comprised of that pool. And then you can see the LUNs that are existing on the storage array. So this is bringing in a third-party array into the Server Manager experience. So you don't have to ever leave Windows if you don't want to. Here we're going to create a new LUN. To do so, we're going to create a virtual disk wizard, because that's the terminology that they use. We're going to pick a pool to provision that storage onto, and just give it a simple name. Any guesses what show I made this demo for? We're going to create a thin LUN, and we're going to create a 500 gig LUN, or 500 gig virtual disk to be provisioned. We'll select our WWPNs that we want to mask this LUN to, and then we just click Create. So you don't have to know anything about storage now. Basically what happened is Microsoft did a vote of no confidence to the storage industry and said, guys, you've had 20 years and you balked it up. It's a mess. You've got all these custom services and custom interfaces. We're going to take control. We're going to clean up this experience for our users, and that's exactly what they've done. Now, I happen to think that NetApp was one of the good citizens, and you'll see why in a second. But as you can see, if you don't want to leave the Windows experience, you don't have to anymore. It's all in box. And it's only getting better with the next version where we're bringing in the ability to zone fabrics for pure fiber channel environments, again, from the single interface management. So you can see now that we've already brought that CSV all the way in through 2 wizards. Took about a minute and a half to get done. Yes, sir.
So the question was, how does it honor role-based administration?
Okay, so from the SMIS provider point of view, when you install and configure our provider, you have to give it a username that's going to be authenticating to the SMIS agent, and then a username and password that's going to communicate to the storage controller. So those are two different authentication points. Now we can do RBAC on the storage controller. So we could take, Corey's server farm, he uses user A. User A only has the ability to communicate or to create storage on aggregates 1, 2, and 3 on the following VSMs. And then Glenn's server farm, well, I'm a global admin, so I can do whatever I want. And then through the authentication, when he points to his SMIS provider, right, or his agent with his username and his tier through credentials, it'll honor those delegations all the way through the stack. Yes, sir.
Is there a minimum version of data on tap for this specifically to work?
No. Every currently supported version of Data on Tap will work. Data on Tap 7.3x and any 8.0 code line, both 7 and C mode. From an API perspective, 7.2, 7.1 would probably work because all of the on-tappies or the APIs under the covers are there. But we don't do conformity testing with versions that old. We haven't shipped 7.1 in 8 years.
Yeah, 8 years.
Yeah. Right. Okay, so that was storage provisioning with SMIS. So now let's take a look at what this looks like doing it from a pure PowerShell experience. So here we have our GUI. This is NetApp On-Command System Manager. This is the GUI for our storage arrays if you choose to use it. And here I have a cluster data ONTAP cluster, Verona, with 4 virtual storage machines or VSMs deployed therein. So what I want to do is I want to onboard a new tenant into my data center. We're going to call this tenant Zach for my adorable son. And to do that, we'll just refresh it here to prove that this isn't a Julia Stiles moment. To do that, we're going to use PowerShell. So here you can see the PowerShell script to do complete tenant-based provisioning. This is going to create a new VSM. We're going to create the fiber channel lifts. We're going to create the volume or the storage pool itself. We'll do user delegation, create LUNs, zone and mask those LUNs, present it to Windows Server failover clustering, on and on and on. What would typically be 3 or 4 or 5 steps, possibly across 3 teams, we're going to accomplish with a single script. At this point, the LUN's already created, so we're done on the ONTAP side. We're just waiting for VSS to discover the disk. And here we can see, in about 30 seconds, we've got our new CSV provisioned inside our Windows Server failover cluster, ready for us to start provisioning VMs on. And then if we refresh on command, we can see that we've got that new VSM fully deployed. So again, from our PowerShell interface, if you choose to do so, we are ready to do full tenant-based end-to-end provisioning today. So that's from a management perspective. Now, Windows Server also had some really cool enhancements from a performance perspective, most of which aren't unique to storage, right? Most of these enhancements are massive virtual machines, slick I/O stacks, RDMA, and incredible network performance, on and on and on. From a storage perspective, they gave us a couple of really cool hooks, but the coolest and the one that we're most excited about by far is offloaded data transfer, or ODX. You guys familiar with ODX? Couple of hands, okay. So what's unique about ODX, copy offload engines have been around forever, but what makes ODX unique is it's token based. Now what that means is it's by its pure protocol nature, it is cross protocol. And that also means that as an array vendor, we can automatically select the maximum offload. Now to understand how this works, we'll just take a couple of seconds and kind of deep dive what happens. So inside Windows Server, anytime, or inside a guest running inside Windows Server, anytime you issue any copy, it could be X copy, it could be right-click mouse copy, Control-C, it doesn't matter how the copy is initiated, Windows triggers what's known as an offload read. Now, when it does the offload read, it queries the storage controller and says, hey, storage controller, do you support ODX? In our case, we're going to be cluster data on tap, and we reply back, why, yes, I do. So it takes that source file, and instead of reading the LBA ranges and starting to stream the data over the network, it breaks the source file up into a series of small LBA chunks. And for each chunk, it sends and it goes to the storage controller, hey, for this LBA chunk, give me a token. And the storage controller will hand back a token, a tiny, tiny, tiny little packet that represents that data. Now the token, not the data, is then sent over the wire. Now it doesn't matter where it goes. It could be to the same host. It could be to a host across the world. It could be it could be from a guest to the parent, but it sends the token itself. When the token gets to the destination drops the token on the storage and says, do you know how to get to this? In our case, it's the same storage controller, and we say, why, yes, I do. And at that point, Windows Server gets out of the business of handling the copy at all, and as the storage array, we get to offload it, right? So that's a really kind of quick and fast dirty over what ODX actually does. But why do you care? Well, let's take a look. By the way, we could do a video where I create like an empty file and then show it moving really, really fast, and that would make us look cool, but it's not really practical. It's not how you're going to use this in your day-to-day world. So to show this from an operational perspective, here I've got Windows Server 2012 with a handful of virtual machines on it, and these VMs are running on an SMB3 share. And I'm going to use live migration. I'm going to use storage live migration as the mechanism to show you what this means. So here we're going to do it all through the GUI. No special tools required. It just kind of works out of the box. And we're going to move this virtual machine from its current data store to this data store 1. Now, data store 1, I've disabled ODX. I've turned it off. It's an option on our controllers. So this is what the host-based copy looks like. And we're just going to let that kind of get going. Now we're going to take this app01 VM, and we're going to move it, and we're going to move it to data store 4. And right away you can see that we get enhanced speed. Well, how do we do that? Well, we just removed about 75% of the architecture out of the copy process. The network switches aren't involved, the storage fabric's not involved, the HBAs aren't involved, and Windows Server and its processors aren't involved. Instead, we handle it all in the storage controller, but all the while you get that same graphical update. You know exactly where we're at inside the process. Now here we're going to take that VM that we just moved once, and let's move it a second time. This time we're going to show off what's unique to our implementation because we have a unified array, all protocols out of a single box. We can actually take that SMB3 share, and here we're using ODX to move it from an SMB3 share to a fiber channel 1, right? Two protocols that know nothing about each other. Typically this would not be possible, but in this case, since the underlying storage is the same, we're able to get the same offload perspective. And from a raw performance perspective, it's about twice as fast. Now, why do I say that? Well, we moved one VM twice in the same amount of time that it took to move one once, right? It's actually a little bit faster because there was some GUIs there and some stuff where we were kind of playing around with it. But from an operational perspective, the real beauty about this is it just works, right? On NetApp storage, you also get the additional benefit of under the covers, we're using our FlexClone engine to actually perform these copies, which means not only are they incredibly fast, but they're space efficient because they're using our dedupe engine. You know, that's how we're achieving this speed is by, quite honestly, not moving the data in the first place. Instead, we're just moving metadata, right?
So the question is, can you do that between devices?
Yeah, so the target for us in our implementation is the cluster itself. So as long as the ODX token is created and dropped anywhere within a cluster data on tap cluster, we will always offload the transfer. Now, there are various levels of offload, right? If it's node 1 over here, node 2 over here, then that's a traditional copy, but it's a copy on our network, not on your production network, and it's not utilizing the resources within Windows Server, so it's not impacting your other guests. If it's within a single controller, then we have standards-based SCSI offload copy, and if it's inside a volume, that's when we're going to take advantage of our FlexClone to just do pointer manipulation. So we have kind of a sliding scale of offloads, but the important part is we will always offload the work from Windows as long as we're within a single cluster, and a cluster can go up to 24 nodes. So we're not talking about a small target here. We're talking about petabytes.
This is a NetApp cluster. Okay, so up to 24 nodes in a NetApp cluster. Can you use PowerShell to execute those moves?
Absolutely. The move VM commandlet inside Hyper-V would do the same thing. We use the GUI just because I wanted to show that it's nothing special, and honestly, I could fake a PowerShell script just by overloading the commandlet. Then again, it's a video, so I guess I could have faked anything, but feel free to test at your own risk. We didn't really make any of this stuff up. It is shipping now. It's been in production for 6 months for us, and we're getting fantastic results in the field.
So just on the subject of PowerShell, with these new NetApp PowerShell commands that you've got, can you do everything with PowerShell, similar to like, say, Exchange or Windows, like everything's built on top of PowerShell?
Yeah, so the question was, with the new commandlets, can we do everything with PowerShell? Absolutely. That's the point, right? So there's actually a core tendency inside our engineering teams that for every single command that they expose via the internal kernel, there must be an API that can be consumed externally. So we have a one-for-one relationship inside our own internal development between functions on the controller and APIs that can be consumed. And then our PowerShell team then implements those APIs as they're produced. We call them Zappies. But yes, anything you can do on the controller can be accomplished through PowerShell. It's really, we don't really try to make bets when it comes to management interfaces. We kind of believe in just enabling our customers and partners. So PowerShell kind of took off organically. We also have Python support and Perl support and Java support. PowerShell is the one that people are using because, well, it's superior. I'm a PowerShell guy, so I'll play favorites there. But as a company, we don't. We also have our own GUIs. We also support standards like SMIS. So we don't try to tell you which tool to use. We just kind of we provide the plethora. We support them equally, and then we let you tell us which ones are working and which ones need more work. Okay?
One more question.
The ODX, is that something that you need to configure in advance, or is it something that it's going to try in a first instance and if it's able to just do it? Or?
Yeah, so the question was, do you need to configure ODX? That's the beauty of it. No. Right? The very first step, they implemented it all the way deep down in the kernel level of Windows. Whenever a copy operates, because a copy is a standard I/O, right? There's no custom code to making a file copy. At this point, it's just a service provided by Windows itself. It's deep down within Windows that they implemented the ODX engine. And the first part of every copy is to check and see if the source is ODX compliant. And then for the actual copy process to check if the destination is ODX compliant. If they are, it will offload. If they aren't, it will fail back to a host-based copy. So there's no risk in this. It just makes it faster. It just makes it more space efficient. And if at any point in time it stops working, Windows goes back to copying it the old way. It is brilliant. They could not have done a better job implementing it. It makes it a little hard for guys like Corey and I because we have to get up here and tell you how great it is because you're never going to notice it. The only way you know what's going on is if you actually study Task Manager or Resource Monitor and start moving some big data because you'll notice that all of a sudden you're moving gigs per second at line rate, but on the network stack, it's just a couple hundred kilos in and out, right? Because those are the actual those are the tokens in flight, not the actual data on the wire. Yes, sir.
Your own tool, are you doing that with your own tool as well? So when you have your GUI tool, can we leverage the best practice bits and pieces that you're doing underneath that to generate scripts from how your tool works?
Right, yeah. So the question was, do we, Corey beat me up in my last session about repeating the question, so now I'm on my toes. The question was, do our GUIs generate scripts similar to VMM or Exchange? Unfortunately, no. And the reason for that is because our tools, for instance, the Server Manager tool that I showed you before, that is not a Windows-specific tool. That is it's an open platform tool. It will run on anything, Mac, Java, Linux. We support everybody evenly. So to put that in there, it would be kind of locking it into Windows. It would look a little out of place. I will tell you, and you'll see it here in a minute when we get to the actual code, that our PowerShell implementation is ready for kindergartners. It's just so easy. It reads like an English sentence. Okay. Yep. So now we'll get to another tenet of Windows Server, which is portability. right? One of the things that they absolutely nailed, we're not crazy about it as a shared enterprise storage vendor, but when they implemented Hyper-V and the data mobility features in there, they made sure that you as administrators had the tools that you needed to be able to get out of everything, except for one scenario. How many of you have VMware in your data center right now? Everybody does. They didn't invent virtualization, but they sure did make it popular, didn't they? Right? So what we've done is we have a little project that we call Project Shift. We had a session on it earlier today, if any of you were in there. And it's aimed at enabling multi-hypervisor strategies and removing the barriers traditionally associated with moving from one hypervisor to another. So when we say portability in this context right now today, what we're talking about is portability into Hyper-V. Once you're in Hyper-V, getting around from one vendor to another, from our array, on it, off it, in between it, doesn't matter. Shared Nothing Live Migration will take care of you. But the problem is, how do you get in? Well, to help solve that problem and to give you choice, we've built a series of technologies that works with Windows Server 2003 and up. It's only Windows, no support for Linux yet, although it is on the roadmap. And it is an order of magnitude faster than a standard copy-based import-export process. It is space efficient because it uses our FlexClone technology, so we're not actually copying any data. We're just swinging a couple 100 million pointers. And it is based in Windows PowerShell. So it is all written in an interpreted language. There's no compiled executables. There's no IP here. This is just enabling you to be successful. You can crack open the script, read it, and see how it works. Now, what happened shortly after TechEd EMEA 4 months ago is Microsoft came to us and offered us a very exciting opportunity, which we jumped at, which was to bake this technology we call Project Shift into the Microsoft Migration Automation Toolkit, the MAT. You guys familiar with MAT? Nobody knows the MAT. The MAT is awesome. MAT is brilliant. So what is the MAT? Okay, so here what we're going to do is we're going to move an environment from VMware to Hyper-V. Here we've brought in our entry-level FAS 2240. That's the smallest controller we sell. To show the point of this is just to give you, you don't have to buy something big and expensive. This is a very affordable offering from us. We've connected NFS to our VMware environment and SMB3 to our Hyper-V environment. Then we're going to bring the MAT in. The MAT's going to perform an initial collection. We're going to store that data off in a SQL Express database. We actually collect the data using PowerShell through the PowerCLI plugin from VMware, so they're kind of giving us the tool to kill them, which is kind of funny. Then we're going to go through and actually do the migration itself. We're going to start by taking a snapshot of the VM and back it up. Part of that snapshot is saving the network configuration for the virtual machine. We remove VMware tools from within the guest, migrate the VM from VMware to Hyper-V, and then configure the network. So far, okay, great. Why do you care? Well, we do it really, really, really fast. Let's see what this looks like. So here we've got our ESX environment. We've got 29 virtual machines. And here we can see this VM's got a static IP address. That's going to be important here in a second. We're going to flip over to our Hyper-V host where we've got the MAT loaded. We've already done the assessment, so we've collected the information from ESX. Now we're going to run a simple script. And we're going to queue up our job. So we're going to create the virtual machine queue for the VMs that are going to be converted in this pass. This tool is built to handle hundreds of thousands. You wouldn't do hundreds of thousands in a single job. Alternatively, we could delete a VM from that list if we didn't want to move it. But in this case, we want to migrate everybody. So everybody in the pool, the list is complete. We hit convert, and away it goes. So now we're going to watch the first VM all the way through the process to understand the steps. We connect to Virtual Center, connect to cluster data on tap. And now we're going to back up that source VMDK for the first virtual machine. Again, this is using our FlexClone technology, so we have a binary bit-for-bit image of the data before we ever touched it. We validate VMware tools, and then we save the virtual machine network settings using VIX integration through VMware tools. And then we're going to drop a hand grenade down that VIX pipeline, and we're going to actually uninstall VMware tools right out from underneath it, because it turns out you have to uninstall VMware tools while you're still running in VMware. If you wait till you get to Hyper-V, you've waited too long. It won't come out. Now that they're uninstalled, we're going to run that actual conversion. This is using, again, our Shift technology. And then we're going to restore that source VM because we want to make sure that the ESX VM is back to the original state as if we were never there. In case something goes wrong, we just shut one down and start the other one back up. Then we're going to start the VM, and now we start the network restore process. While the network restore process runs, we're going to connect into this virtual machine, and we'll watch it. Here we can see the VM came out. And then here's the GUI run one script that we planted on the VM while it was still in VMware to restore the network settings. Once it's done restoring the network settings, it's going to automatically shut itself down. That triggers Matt and tells it that it's done with this virtual machine. Matt will grab it, flip the MAC address from the static one that we set to identify the adapters back to a dynamic Hyper-V MAC. You could also tell it to use static if you choose to. And then the VM comes up, log into Server Manager, and there's that IP address that we set earlier, right? So this is complete end-to-end migration. From ESX to Hyper-V, completely automated. By the way, that virtual machine took a 5-minute outage to make that jump. That's faster than any other tool in the market. Yes, sir?
Questions. Does that work with RDMs as well?
Yeah, so if they're physical RDMs, yes, because we can reattach those physical RDMs as pass-through disks inside VMware. If they're virtual RDMs, no, we would first have to convert them into VMDKs to do so. Yes, sir, another question. Yeah, absolutely. So and by the way, the question was, did we turn these machines off before we moved them? Yeah, we had to. They are powered off during the migration. What we like to say, and here you can see we've converted all 29 VMs. Total time took about 90 minutes in the real world. You can see that the conversion times were very consistent, about 330 seconds each, all the way through the stack.
Just another question.
Let me finish with this gentleman first. What we like to say is it's cold conversion technology at warm conversion speeds, because we're down for the duration of the migration, but we're doing so in speeds that traditionally are associated with products like Double Take, where you're doing a warm conversion. Yes, sir?
So you just sell this as a solution? Or?
We don't sell it at all. It's on the Microsoft website. It's available to our
Like in terms of like having a NetApp appliance in between.
Yeah, so it works with.
Like we don't have any NetApp at the moment, but
Yes.
if you're trying to encourage
Got it.
people to think about things differently.
Yeah, so the question was, do we sell this as a solution? For non-NetApp customers, there are a couple of options. There are partners that could take this, and if you're a partner, you should think about this, because I think there's some business for you out there. They could take a handful of controllers in their own little fleet and stand up a migration service going from shop to shop to shop and just helping them get from point A to point B. Honestly, we understand that in that type of relationship, you're not an NetApp customer, maybe you're not interested in being one. We're just solving a problem there. But I would say, remember us next time you get around to bid, because apparently we can solve problems. Now, from the actual implementation perspective, you'll notice that in this example, we were using the smallest, cheapest controller we have, right? So you wouldn't need to put your entire farm. If you had 100,000 virtual machines, we're moving 30 at a time. So SV motion 30 VMs onto us, flip them, and then storage live migration back off. There's nothing wrong with that. A couple more questions in the back. Yes, sir.
What happens for the existing environments which we already using, say, NetApp storage?
Yep. So the question is, what happens to the existing environment? If it's already running cluster data on tap and you're already running on us, we actually don't move any data. We're just doing pointer manipulation, right? So all the source VMs stay in place, and we don't consume any additional space. So if you had, sorry about that. That was a bit rude. That's what I get for drinking a soda up here. Trying to keep my voice through this. I was at VMworld last week. This is 2 weeks straight of talking. So if you had 10 terabytes of VMs inside your vSphere environment, and then we shift 10 terabytes to Hyper-V, now they would actually only consume about a gig of actual differential space in between the two, and that's just in the metadata differences between the file formats themselves, right? So that's really the value prop. Since we're not copying any data, we don't require additional swing space. We're literally just creating additional pointers to the current file so that you can make the migration. Yes, sir.
This works on VMware that's configured in the clusters, or is it one server?
It uses, so the question was, does it work in VMware clusters or just a single server? We use the VMware APIs, so all of the above, yes. Another question.
What about VMs that are SRM enabled?
So the question was, what about SRM? SRM is a bit of a sticky wicket, because there you're going to have RDMs and you've got DR play. That's kind of a more complicated engagement. We're not trying to solve the complete platform problem of here was your portfolio and your architecture when you're in vSphere. Now you're in Hyper-V. How are you going to solve all those problems? That's an opportunity for other partners like Microsoft to handle that. What we're solving is, here's a VM. I want the VM in Hyper-V, but I can't go down for 2 hours to make that migration. Yes, sir. Absolutely. That goes back to our SDS definition in the beginning. With our V-Series line, we can take our software and essentially virtualize an existing array. So go ahead, go spend a ton of money on VMAX. That's fine with us. Give us a tiny little check, and we'll make that VMAX worth something. Yes, sir.
Are you able to then migrate the machine in place the way you want?
Yeah, absolutely. That is exactly what we're doing. We're doing an in-place migration without actually moving any data.
Are there anything that compromise when you're migrating from VMware to
So I think the question is, are there any compromises? Okay, so is there anything else that needs to be modified post the migration? So we obviously picked up the network settings, but is there anything else?
Yeah, so there might be, right? That's part of the reason why. Sorry, guys. Apologize about my cough. That's part of the reason why we map for shift, by the way, out of the box won't do a job with more than 30 VMs. Because realistically, right, you'd be sitting there and you'd kick off this job and you'd have VMs that are shutting down over here and then popping up over here. And you as the administrator, at the end, every 3 minutes would get a new VM that would pop online. You'd log into it, make sure your services came online, make sure everything came through the transition successfully. This is very much a one-way tool for a one-time job. Project Shift, which is the other thing that we talked about earlier today, is aimed more at making all of that seamless, but that's not ready yet. That's more of a roadmap thing of something we're working on. Yes, sir. Last question, and then let's get on through the rest of the deck.
Hyper-V gives us the virtual HVA, so we don't have to do RDMs in VMs. Is there any support in toolkit for migrating from those kind of RDMs?
Got it. Yeah. So the question is, virtual fiber channel negates the need for RDMs since we can present a LUN directly into the guest. No, there's no support inside MAT for that scenario. However, I will tell you that inside data on tap, a LUN is just a file, and we have unified protocol access. So let's say, for instance, your source environment had RDMs configured physical pass-through using iSCSI. You could move that VM into Hyper-V, take the same LUN, change the source initiator from an iSCSI initiator to a fiber channel initiator, present it to those virtual WWPNs, and it would just come right into the host and work just flawlessly. It's one of the advantages, right? But part of this too, we're not showing it here, but we can actually take LUNs, convert them into VHDs, take VHDs, convert them into LUNs. At the end of the day, we have an intelligent data management platform with 2 or 3 layers of abstraction between the physical spinning disks and the servers that communicate with those disks. And it's because of those layers of abstraction, and it's because of the intelligence inside our operating system that we're able to do these cool tricks. Okay, so let's kind of brush through here. I'm going to accelerate some of this stuff because we got quite a bit to get through still. So now that we made this migration, how are we going to back it up? Well, at NetApp, we have an answer for that. That's our Snap Manager for Hyper-V version 2.0 product. It is a hardware-based snapshot provider. What that means is we use array-based snapshots. We don't use VSS copy on write cloning. We support what we call crash and application consistent backups, and we'll get into why those matter here briefly. It works with CSV, and with CSVs, we do implement the new distributed backup feature. What that means is when you used to create a VSS job, it would have to go one at a time through each VM, one at a time through each node in the cluster. And you'll see in the next slide that led to incredible backup windows that just went on for days and days and days. And as a backup services provider, you would yell at us, and we would take the brunt of the hit, but then we would turn around and go to Microsoft and go, can you please help me and fix this? Well, that's what they did. Distributed backups, take that VSS job. You got 16 nodes in a cluster. You send one VSS query. It sends it out to all 16 nodes, and all 16 nodes quiesce at the same time. So we're able to exponentially decrease the backup windows. And then, of course, with SMB3, now that we've got VMs sitting in file shares, we need ways to quiesce those as well. That's what remote VSS is. We're going to skip over the video. But why do you care? Quite frankly, performance. Now, I'm not going to tell you how much faster we are than other existing software providers, you can look at these backup windows and in your own head do the math of how fast your current solution would take. But just compared to our own service, we did a head-to-head. And here you can see we took Server 2008 R2 and Server 2012, and we did a bake-off. The blue bars represent 500 virtual machines running on 8 nodes. The red bars represent 1,000 virtual machines running across 16 nodes. You can see with Server 2008 R2, application-consistent backups, it was taking us 300 minutes to back up 1,000 VMs. Our customers told us that, quite frankly, just wasn't cutting it. That's not what they needed. In Server 2012, that same backup job is down to 62 minutes. That's a manageable backup window. That is fully quiescing the guest file system for all 1,000 virtual machines and placing them under the protection of a single hardware-based snapshot, which can then be replicated anywhere in the world for DR, TEV test, anything you can come up with. Now, what's really exciting is when we take a look at the crash-consistent backup options. What is crash-consistent? Crash-consistent basically means that we put the file system in a crash-consistent state by not calling VSS before we take the snapshot. So in the event of doing a restore from a crash-consistent snapshot, the server would look as if you just yanked the power out. Now, people look at that and they say, why would I ever do that? Well, what's running inside the VM? If it's an Active Directory domain controller, don't ever do that. That's a really bad idea, and it's a good way to corrupt your domain. But if it's an Exchange server, and you're running Snap Manager for Exchange or some existing product to back up your Exchange database, then the job of your hypervisor snapshot is to get the OS back. It's not to get the application back to a healthy point. You have a different product that does do that. So in that scenario, what you want your hypervisor snapshot to do is just to give you a point at which you can run your app restore from. So in that kind of scenario, crash consistent is actually a better answer. And using crash consistent, if we take a look all the way at the end of this bar, we were able to back up 1,000 virtual machines in 12 minutes. Yes, sir?
Is it crash consistent across all volumes?
Yes. Yeah, the question was, is it crash consistent across all volumes? The answer is yes. We cannot do mixed jobs, so we can't have a job where one VM is app consistent and 99 are crash consistent. Those would be 2 separate jobs, or what we call data sets. But you could configure it that way, but they couldn't run concurrently at the same time because only one application can call VSS at a time. But what's really exciting about this is all of a sudden now we're giving service providers and enterprise customers the ability to offer backup to their customers as a service, and potentially offer a 15-minute RPO for crash-consistent VMs. That's actually, it's kind of unique, right? Every 15 minutes, you have a recovery point that you can replicate to anywhere in the world and keep up to 255 or 32,000, depending on how you choose to archive. So that's our backup product. If you'd like to know more about that, come on down and see us. Again, we got to kind of cruise through some of this stuff because we spent so much time on VMware to Hyper-V, but it's okay. I understand why. That is the pain point that just about everybody is talking about these days. So now let's get into the cloud. Now, of course, when you hear private cloud inside a Microsoft context, your brain should hear the word System Center because that's really what we're talking about, right? Microsoft Private Cloud equals System Center. In this case, we're going to talk about System Center 2012 SP1. In 6 weeks, it would be 2012 R2. But generally speaking, none of this stuff changes. Our integration components stay the same. The capabilities stay the same. What changes is the underlying version. So from an integration perspective, first and foremost, of course, we do offer a SCOM plugin because step one of anything is monitor it. If you don't have the data coming in, how can you make intelligent decisions about anything? So in this case, we like to consider our SCOM plugin, the centralized storage management for the Windows administrator. So you don't know anything about storage. You're not interested in learning anything about storage. You have a service provider, of which I hear there are several very quality ones here in this country, who implement it for you. SCOM is a simple way. Our management pack is a simple way for us to bring the intelligence of the array and all of the management details into the panel you're already using. We also do provide a series of reports, just for in case you use SCOM as part of your quarterly roll-up reporting. Of course, if you're doing that, you probably already know how to write your own reports. These are really just samples. Just know that everything we collect goes into the data warehouse. So you can do long-term analytical decisions based on the data in here. We keep capacity, performance, usage, change rate, all that good stuff. And then we also do offer SCVMM Pro Tip integration. Mainly, so the pro tip integration is aimed at and comes from our customer service success services, CSS, that's what we call our support guys. Basically, they come to us about every 6 months and say, well, in the past 6 months, here's what customers have been doing incorrectly. And then we take that and we add it into the Pro Pack and we kind of walk our way through these problems. And we try to get SCOM intelligent enough that perhaps we can avoid a call to support and we can give you the ability to auto-remediate and solve your own problems or point out that you have one that potentially you didn't know about. Stuff like misconfiguring thin provisioning, that's a big one. Thin provisioning is absolutely fantastic. It enables you to achieve efficiency ratings that are otherwise unimaginable. The problem is if you do it incorrectly, it will cause an outage. It's not a matter of if, it's when. Right? So when thin provisioning is turned on, it must be configured correctly, and that's a big one here. Going through and making sure the space reservations, the snapshot, auto delete, auto grow, all the bells and whistles are configured correctly to run thin provisioning safely in the enterprise. New to 2012 SP1. We had been asking the VMM team for years, and it's just all the way back to 2005. Just give us an integration component. Customers love your product. We want to work with it. 2012 SP1, they gave us that integration. It's called a GUI add-in. Have you guys seen these before? Yeah, any of you using GUI add-ins? Yeah? A couple guys. Cisco's got some great ones. If you've got UCS kit, we use them in FlexPod in our architectures. They're absolutely fabulous. We shipped, our first GUI add-in was aimed at solving the number one thing our customers asked us for, which was the ability to do cloning and provisioning using our FlexClone technology, or what we call sublun cloning. So here what we've done is taken this not new, I mean, we've been doing this for several years now, but here we're integrating it directly into VMM. So we're giving you a simple button. You click Clone VM. A little modal dialog pops up. Tell it what you want the base name to be, how many clones you want, where you want them to go, and whether or not you want them to power on. You hit clone and you're done. Right? Now, this is kind of, there are some restrictions to this, right? Think of this as the easy button. Easy buttons do one thing. You push it, it says that was easy, right? There's no way to make it say something else. Joke may not play as well here. But in this case, when you click clone, it's going to clone a VM. If you'd like some variety, that's where our Data on Tap PowerShell toolkit comes in. That's where those API support come in, right? And then we've got the Grand Poopah, which is the heart of the Microsoft private cloud and the heart of any modern data center these days. System Center Orchestrator, formerly known as Opalis. We like to think that our Opalis integration, sorry, slip of the tongue there. I've been playing with it for several years at this point. Our Orchestrator integration is best of breed. We ship 29 OIPs, which provide object-level management at all layers of the system, stuff like create a log, create a volume, create an aggregate, delete an aggregate, create SnapMirror, update SnapMirror. We even have some DR commandlets. They're not as, just being truth in advertising, telling you the honest truth, they're not as useful in Server 2012 as they were previously, but they work with 2008. So we actually shipped the ability to do full DR with Windows Server 2008, which out of the box didn't do any of this stuff. So we had to do a lot of work to get it to work. With Hyper-V Replica, Windows now just kind of does that for us. So again, we stepped up and filled a hole in the product. Now that the product has kind of filled some of that back in, now we're moving on to the next problem. And we kind of work that way together through the solution stack, and we'll continue to try to make this easier for you. So now let's take a look at Orchestrator. So here we have, this is the actual environment that we submitted to Microsoft for our Microsoft Private Cloud Fast Track v3 reference architecture, the FlexPod that we released at TechEd this past April. What we had to do is go out and provide the documentation to Microsoft. They came out, validated our deployment docs. We built it in front of them. After it was built, we handed it over to them. They played with it for a couple hours and said, yep, you got NetApp Cisco, you did a good job. This is the actual environment. What you're about to see is the actual, one of the steps that we had to do was bare metal provisioning. That's on the checkbox. You must support bare metal provisioning in order to be Fast Track 3.0 certified. So what we're going to do is we're going to do some bare metal provisioning, right? So we're going to go to VMM and say create bare metal. No, this is a cloud, right? Self-service. Do it. Don't say it. So we're going to go to our self-service portal. We're going to call up the service request offering that we've created here to add a FlexPod VM host. We're going to give it a simple host name. We could alternatively give it a UCS server pool, but it's not mandatory. And then we're going to go in and view the service request offering. Now, because this was for a validation effort, did we stop? We did. Now, because this is for a validation effort, we configured it to auto-approve, so we're just going to hit refresh here, and we'll see that the service request approval will go straight into completed. In progress, hit refresh again, and completed. And now that the actual provisioning task is running, let's flip over to Orchestrator itself. And now we're going to pause it here for a second because I want to actually walk through this workflow. You know, one of my coworkers joked that this looked like an AK-47 to him, which I got to admit it does kind of a little bit. But okay, so what are we actually going to do? So we're going to take our that service request offering, and we're going to take the host name. We're going to initialize the data, validate that what we got back is sanitized and good to go. Then we're going to clone our service profile inside UCS Manager to provision the virtual server pool. Then we're going to use the advantage of Orchestrator to do parallelism. We'll associate that service profile. While it's associating, we're going to go through and zone the fiber channel fabric. Again, something that gets way easier here in 6 weeks. But a year ago when we did the work, it was way harder to do this because we didn't have support through SMIS. So we manually zone the fabric. And we're going to use our own APIs to clone a bare metal LUN, so a LUN that we've sysprepped and staged. We'll then mount that LUN to a midwife host where we're going to inject a custom sysprep and write a new disk GUID signature. And then we'll mount that LUN back into the service profile, wait for it to start. Now, the interesting thing is it's only going to take us about 12 seconds to install Windows. But it's going to take 15 minutes to deploy this host. The reason is we've got to reboot the server twice, and a UCS blade with 96 or 128 gigs of memory takes about 6 minutes to reboot. So now we'll hit play and watch this thing go in real speed.
Can I ask a question that's a bit off?
Yes.
So with the new, with 2012 and the storage tiering, how do you support that with your NetApp appliances?
So the question is about storage tiering in Windows Server 2012 R2. I will take that once we finish up here in a second. That is a good question. Okay, so here the service profile has been associated. And if we hit refresh, we can see that we've gone through all that mess that we talked about. We've zoned the fabric, we've done everything, and now we're waiting for sysprep. So we're going to go back into that JVM console. We flash forward a little bit there because, again, that's a 6-minute pause while the server reboots. We can see that the LUN that we provisioned, it's going to go ahead and run its auto run and start up and do the run once scripts that it has in there. And then if we go into Server Manager, we can see the host name that we set inside our self-service portal. But if we go back into the Orchestrator runbook, we'll see that we're still running here. And that's because the last thing that we want to do on the way out before we complete this task is we need to add this host back into VMM. Because VMM, of course, is the master of our hosts inside a Windows Server environment. So the last step to any workflow is to add it back in so that we can manage it over the life cycle. So that's bare metal, host-based provisioning from a self-service portal to VMM in about 15 minutes. We're pretty proud of that. Okay. Sir?
How did it know what host you were connecting it to? Is that?
Yeah, so the question was, how did it know what host you were connected to? So in that case, the host auto-configured itself. It came up. We had some scripts that we injected while we were at the midwife to configure the network, to configure the domain membership. And then the last one is to actually call out to VMM and add itself into VMM. So we didn't have to know its IP because it knew its IP. And then once it contacts VMM, now we have agent-based communication using the sit of the box, so the name doesn't matter at that point. So the answer is we didn't, but we didn't need to.
Who's providing the service
what was providing the self-service portal there?
Yeah, so that's Service Manager. That was the Service Manager self-service portal. We just used the Service Manager integration to extend out and add that service offering. So that's as basic as it gets, right? That could have got way more advanced, way fancier. The point was just to show our customers that we were ready for cloud. So, in summary, we like to say, what if you could save on your power, space, and cooling by at least 50%, rapidly provision virtual machines and physical hosts via orchestration, do all of it through self-service portals, all while achieving non-disruptive applications. Well, if that's something you're interested in and you're looking for a single source vendor, we would like to introduce you to our FlexPod for Microsoft Private Cloud Reference Architecture, which, by the way, was the winner of Best of TechEd in the server management category at TechEd North America this past July. It is a Fast Track 3.0 validated design, fully integrated with Server 2012 SP1 and the Cloud Service Process Pack through Service Manager. It's based on FlexPod, and we believe it is the most scalable Hyper-V platform in the market right now. All hardware components and reference architectures are available today. They've been available for a while now. You guys can just go out there and get more information if you're interested in. We do understand this is a bit of a kit, though. This is a lot of gear. Right, and for some customers, they come to us and say, hey, we love the FlexPod thing, but I just don't need all that. Well, to address those markets, we've introduced FlexPod Express, which is an entry-level reference architecture. It is iSCSI only, so it's not fiber channel and all the complexity therein. Apologize again. We've documented small and medium configs, 2 and 4 node services, and again, all hardware components as well as the reference implementations are available today. So in summary, we talked about who is NetApp, what are we? We're a storage company. We are the caretaker to Data ONTAP. We talked about software-defined data centers and software-defined storage, and the fact that we're trying to get out in front of this one before everyone's sick and tired of the term. We'd like to define what the term means for once. We talked about our integration with Windows Server 2012, specifically around SMIS and PowerShell, and then our industry-unique ability to implement ODX not only within the host, but across protocol ODX. We talked about Project Shift and the ability to migrate VMs from VMware to Hyper-V, and back again, by the way, just in case you need to. And then we talked about our integration with System Center 2012 SP1, aka the Microsoft Private Cloud. So ladies and gentlemen, don't forget to fill out the eval. I was a 5, right? You know, I apologize for the cough, but we did try. Look up your other resources while you're here. We got one more day. And make sure to come by the booth if you have any more questions. Thank you very much. I hope you found this entertaining. We're going to make sure to give away the Sonos system, and then we're going to talk about tiering inside Windows Server 2012. So any other questions besides tiering? One.
Well, it transfers over from VMware. Does it also work in a way to actually get a refund from the misspent money that you made?
So the question was, is there a way to get a refund that you misspent on the VMware system? No comment.
Okay, so we are out of time. Thanks very much, Glenn, and thanks for all your questions as well. Now, we do have the Sonos Play 5 wireless music system to give away. So hopefully you all got scanned on the way in. And we've drawn the winners. Well, the winner, sorry, there is only one. Is Andrew Blake from Department of Defence here?
Andrew Blake. Thank you very much, sir. Alrighty, folks, thanks again.
Thank you again.
It's been a blast. I hope you guys learned something. Okay, so